Hi, I'm Kon. I'm your speaker, obviously. Um, I'm from Greece. I'm a Flutter developer. I also do design. My pronouns are he, him, and for whoever who's unable to see, I'm a white man with a black t-shirt. Today we're gonna talk about two things: responsive UI and Flutter Web. They're connected. Just a quick check as we start. Who here has already used Flutter Web at least once? Oh, nice. Okay, you probably know it's like a way to use Flutter to write websites. It's similar to how Angular works or React works, but with Flutter. And most things that you do on mobile will work on a web, but there might be some extra like configurations or things that you need to do to make it work well, and that's what we're gonna look at today. Very quickly, the agenda, we're gonna spend like around the first half talking about responsive UI, what matters, how we can implement it, and things like that. We're gonna see some code, but not too much. In the second part, we're going to look at some nuances of the web. We're going to talk about conditional importing, about SEO, and then we'll have time about some widgets, and then we're going to have time for a Q&A. Some good things to know about the speed. You can get the slides at the end. They're going to be a QR, so you can take photos, but you're also going to have them. If there is images or video, especially in the first part, I'm going to verbally say what it is, so if you cannot see them, that's also okay. And look for the focus. So, responsive UI. Pretty much responsive UI is how you're building your website, your UI of the website in a way that works for different resolutions and different sizes of screens. This became more popular as mobiles came to be because then there's a very big difference in the screen size. There are a lot of things that can go wrong if it's not taken care of. Some examples about why it matters. If you build a website, it's going to inevitably be used on a desktop and on a mobile. And here we can see a website where it has like a header, an image, and some text in a row, but in the website the header breaks and the image overflows and doesn't look good. And here's another example, which is the same website with a large cookie notice, and the cookie notice gets so big that the buttons are hidden and you cannot use the website practically in a mobile. And this is actually a real example that I have come across. And here's the opposite case where it looks good on a mobile, where everything is in a column, but in a website it's not resized, so the website looks empty, and this is also pretty bad. And even in cases where we only have a website that we use, that's not going to be the case, but even if it is, because the screen can be resized, and here we have a UI with two columns that is resizable, as it gets smaller, it can break. So even if you only tend to support desktops and web, you might still have small screens. What we want instead is this behavior, where we have the same thing with two columns, but as the UI gets smaller, the second column transforms and becomes text input, and they become a row, one below the other. This can also be seen as a type of UI. I'm going to use the terms interchangeably here. So a few months maybe ago, Google released a guide on how we can build adaptive UIs. They did this in Google I/O and it has three steps: abstract, measure, and branch. The abstract step, the idea is you find what you want to have differently in a different type of screens, and you're going to abstract its behavior and kind of define what you can have. In our previous example, in the larger screen, we want to have a large text field with two buttons and some extra text. But in a smaller screen, we want to have a single text field with one button which could change between sending a text and uploading a file or an image. These things will have the same behavior, but they will look differently. And then we move to the measure part, which is pretty much like the how we are going to implement the changes. And here Google recommends using either media query, the size of, or layout builder. And we're gonna see exactly what those are now. Media query, so this is the signature of like the function, and you can see that it's something that returns a size object. The size object contains the screen's width and the screen's height. Also, the size of method might sound familiar to your of method. This is because you get that through an inherited model, which is an extension of the inherited widget. You can also use .off. There is media query .off, but it gives you back more details, not only the width and height, and it gets performance, so it's better to do it like that. And there is also build context. which, well, it's pretty obvious, but what's important here is that this function will trigger rebuilds when the screen size changes. So in the previous example where we got like a web browser and the size was modified manually, it will trigger a rebuild and the UI will change. This is the code of how this will be used. So it's pretty straightforward. We have the media query size of there to get the width of the screen, and then we compare it with a number. Here we use 620 and we're gonna see why. And then if it is smaller, we return the small screen. If it is larger, we return the large screen. And now we can go to the layout builder, which has a tiny bit more complex signature. The first thing we can notice here is this is a widget, so it can be directly returned from a method, a build method. And it includes a function which is a builder. This is similar to how future builder works, stream builder, block builder, pretty much a function that returns a widget. This function exposes this constraints parameter, and this is another way to get the width and the height. An important difference here is that the width and the height is the width and height of the parent, not of the screen, which can be the same, can be differently. We're gonna talk a bit about more in the future. The code is still pretty simple. We return a layout builder here, which takes its lambda as a parameter, and we use again the width. We compare it to 620. We can return smaller, large screen depending on what's the case. So how do we choose between the two? If we want the screen size, or practically the window size, if the window is resized, we can use media query size off. If we want the parent size, we can use layout builder. If the widget is very high on the tree, it's very similar that these things are the same, and then just pick whatever you like to write more. If it's lower and the parent size is constrained, then the layout builder will have a different zone. And then we have the third step, which is the branch, which is where we define the breakpoint. And this is, okay, once we now know what's the width, how do we pick if we want a small or large, like what's the width that defines what happens. And here we can look at material guidelines, which have this beautiful table, and it defines three different types or classes of windows. We have the very small, which is the compact, which is when the width is less than 600 dp. And this is practically a phone in a portrait mode. It's like a traditional small screen that you can think. A medium screen, which is like a tablet or a foldable phone, which is open, is between 600 and 840 pixels. This is the rarest, but also something to consider. And then we have the expanded one, which is above 840, and this is a desktop or any device or landscape. And something which are important to consider here is that a phone, which we can like think that, oh, it's a phone, has a small screen. If it's on landscape, it will have the expanded screen, but it will have very small height. So we need to make sure the UI could also work with a small height but large width. Also, the desktop will look as expanded, but if we resize the window in the desktop or in the web, then it could very easily be at the compact area. So even though the devices are usually found like that, there is no guarantee by the width size which device the user is using. The code of how we can implement this is pretty simple. Just define these values as constants in some file to avoid having numbers all around. Then you can create some util functions which pretty much just check the conditions we saw in the previous table, and they will return true or false depending on that. And now the code is changing. So instead of just randomly doing comparison, we get a boolean of like is compact screen, and if it is, we return the small screen. Otherwise, we return the large screen. Again, here, since we're using size off, it will rebuild every time that it's happening. So in a window which is moving, we're going to have a good behavior. So some cool things that you can do with that, cool and easy. One is animations. This is from another website that I had developed. In the video, you can see if it plays. Here we have a cookie notice, and I want the cookie notice to go higher or lower depending on the screen size. So as you can see in the video, the movement is gradual. It's not teleports here or there. This is because there's an animation which does that. The cool thing is that it's pretty easy to implement that, what we've seen. So again, you can measure and get if it's a small screen. Here I use a layout builder, and I get the constraints and the max width. And you can branch, and here based on if it's a small screen, we return a specific padding, but because we're using the animated padding widget, Flutter will take care of having an animation. So as the width screen is changing, the widget will move in an animated way. And this helps make the movement of the change look smoother. And another thing we can do is you can just directly use percentages of the screen when you use the MIDI to size of. So here I have a screen where the horizontal padding is always 2% of the screen size. And this means that it will look pretty good on both mobile and desktop, and it's on the standard value. You can also do the same with an image size if you want to have an image of a percentage. And it's just an easier way to use that without having to do the conditional branching. Okay, let's take a break here, and then we're gonna go to the second part, which is some more nuances about Flutter Web. So the idea of this part of the talk is that there are certain things which will work on desktop or mobile, but not on the web, and the other way around. And these are things to keep in mind when we're working and when we're choosing Flutter for a web project. The first one, which might be the most obvious, is the conditional importing. The thing here is that there are certain packages which work for the web, but not for non-web platforms, and the other way around. The traditional one, like Dart.html or the newer package web, which is to access HTML5 APIs. There is Dart.js and Dart.js interop, which is to work with JavaScript, and of course you can do it in a native platform. And there is Dart.io, which is to work with files and directories, but doesn't extend the web because browser is a sandbox. So pretty much, if you try to import any of these packages in the other platform, you will get a crash during compilation, and you can build up. Of course, you need to have a way to manage that. A use case for that could be that you want to have something which you want to show users who are using Firefox, for example. Let's say Mozilla Foundation is doing some fundraising and you want to inform the Firefox users about it. That can be pretty easy because there is, for example, this function which can be like, okay, it's true if users are using Firefox, but this is part of Dart.html, which means that if you try to run this code on Android or on iOS or whatever, it's going to break. So we need a better solution. The way to use conditional importing, you want to create at least two files. The first, let's call it webutils.js, will look like that. This will import the Dart.html thing you can see there on the top. And then it will define a class, which we're going to call webutils. And the function is Firefox, which will return true if the Firefox is used. Then we also want a no webutils file. This one, we have another class with exactly the same name, and that's important. But here, we do not include the import statement for Dart.html. Of course, if it's not in the web, it can be Firefox, but it's always returns false. And then we need to import the correct one, which is how you do it. So pretty much the syntax says that if Dart library HTML exists in the current platform, return or import the web file. If it doesn't exist, fall back to the non-web file. And this will guarantee that the Dart HTML which we saw before, here it is imported, will only be imported if it exists in the system here. And the code will look like that. So we will create an instance of webutils and we will call the function we want. And webutils here, that's why I told you that the name needs to be the same, because we will go to the proper package above and it will find which one needs to import and we'll get the correct one. Also use the case web value there, so I'm just gonna very quickly tell you what this is. This is a function which returns a boolean. It's a getter actually. It's part of Flutter Foundation, so it exists in every platform, and it's true on the web, it's false on non-web. That's a good way to separate between logic or UI, which is web specific, or mobile or desktop specific. For example, let's say you want to have a download the app button only on the web, and that's a good way to do it. This is also good because, as I told you before, the width doesn't guarantee the platform, but this does. But this cannot be used for conditional importing because this is only available in the behavior when the code is running, but the conditional importing needs to happen before the import is, so you can't use it there. But it's still pretty handy. And now we're going to talk a bit about SEO. Is there anyone here who doesn't know what SEO is? Makes sense. So pretty much SEO is how a search engine finds or ranks your website. And there is a conflict here with Flutter, and we're going to see why. So pretty much the way that most search engines work is they have some robots which they call crawlers, and those robots search the internet, they visit the websites, and they rank them based on certain features that they have, mostly by using the HTML code of the website. Then, once you search something based on the ranking that the sites have, your search engine will show the result that you need. What's important to know here is that the search crawlers, they don't play very well with JavaScript. So when a website is very JavaScript focused, very JavaScript heavy, or the HTML of the website is generated by JavaScript, the crawler will generally rank it much lower and visit it less often. And the thing here is that the way Flutter works on the web is that it uses JavaScript. So when you want to start something that's called in index.html in the web folder, it's generated by default, but the idea is that you download a Flutter.js file and then you run JavaScript to initialize the Flutter engine. And then once the Flutter engine is initialized, Flutter will draw the widgets on the screen, and this will then generate HTML. If this code didn't exist, which I have commented down here, you would get a white screen. And this is the initial view of the application on Flutter Web, which will then, once the JavaScript runs, show what you need to show. The problem is that a crawler will mostly see that. So they will see that your website is a white screen, so it will rank it very low because who wants to see a white screen? So practically, when you're using Flutter, your website will be ranked very low in a search engine. But that's not the Flutter problem. That's a problem with every framework that uses JavaScript. So Angular, React, Vue, all of them, they have the same problem. And the good news is that because everybody has their solutions, the bad news is that none of them is pre-built for Flutter yet. The two things we can do here, one is we can create two versions of our website, one as a landing page using some form of technology which supports SEO like WordPress, Webflow, whatever, and then use a subdomain to create the actual platform of the app, which will be the Flutter. This makes sense, especially if the Flutter part is behind the login, because crawlers cannot see behind the logins. So you just have a landing page, and then once the user log in, you redirect them to the subdomain, and they can do whatever they want to do. This allows you to avoid any issue with SEO because you can use SEO-friendly technologies. But this can't be the case in every website. Not every website can be separated into parts. So there is also a technique called server-side rendering. The idea here is that what the crawler normally does is it asks for the server to provide the website, and the server will respond with this JavaScript heavy version, which the crawler will now see, don't like, and rank very lowly. Instead, what SSR does is that's a step in between where this website is rendered on the server now knows the HTML and sends the HTML to the crawler. Then the crawler sees the HTML, is happier, and ranks the website higher. It still has some issues with loading times and things like that, which can be solved by caching, but it kind of works. The biggest issue here is you have to obviously have some sort of backend which will enable this to happen. You can use like Dartfrog or Serverport to write that, but still is an extra thing to maintain. In many JavaScript frameworks, this is solved by default by the hosting platforms. We don't have it in Flutter yet. Hopefully someday it's going to solve the issue. But overall, Flutter works so-and-so with SEO, and if you want a site which is very SEO focused, maybe not the best idea. And now we're going to see the final part, which is some widgets which are working differently on the web but only useful on the web, or some things, tricks, whatever you can use on the web. The first thing is on the widget. The first thing is the white loading screen we talked about before. And this screen doesn't only mess with SEO, it's also not a nice thing to see when you open a website for 1 or 2 seconds. There are ways to optimize the Flutter initialization time, but this screen will almost always exist. The good thing is that you can customize the screen and do whatever you want. If you go to the index.html file, which is the web folder, you can write any HTML code that you want there. And this, you can add an animation, you can add a loader, you can add pretty much anything to make the process or how it looks like look good. And then once the Flutter is loaded and started, it's going to override anything, so none of this can be seen. It's a pretty cool way to not have users seeing a white screen when they open your app for the first time. Another thing that you need to consider on the web is text. In Flutter, text is not selectable. So that's a video where I pretty much select some text and then can't select some other text. This makes sense because on mobile, you rarely need to select text, but on the web or in any platform with a mouse, it kind of breaks. Fortunately, we have the selectable text widget, which allows us to have text which is selectable and other than that is identical with text, and selectable text.reach, which is identical with rich text. Something to keep in mind here is also a selectable area, which makes all of its children selectable, but this is not, sometimes it breaks, especially when there is clickable things beneath it. Another thing that doesn't make sense on mobile but is needed on the web is the cursor changing. So if you try to click something on the web or place your cursor on top of the gesture detector, it will look like that. Fortunately, we have mouse region, which allows for the cursor to change and have some feedback about, oh, this is a clickable action or whatever. It's worth considering that this doesn't have to be a click cursor. It can be anything. It can be a select cursor or whatever, but it's very handy there. Don't use it to avoid system buttons or material buttons. They are obviously better because they also take care of accessibility and other things. But if at some point you really need this behavior, you can use a mouse region. And probably the last one, we're going very fast, is adaptive scaffold, which is a widget provided by Flutter in a different package. And this one separates the screen in six areas. You have two navigations bottom and top, two navigations primary and secondary, left and right, and then a body and a secondary body. Not all of them needs to exist all the time, but this is kind of how adaptive scaffold, which can replace normal scaffold, splits the screen in. It works like that. So you have an image UI built with adaptive scaffold, and as the UI size changes, the primary body will always be visible, but the secondary body might be hidden. The navigation from the left might be only icons or icons and text, or it can become a bottom navigation at the bottom of the screen. The idea here is to make it easier to have all those different states in a screen without having to implement them. Adaptive scaffold works with the same table we saw before, so pretty much it separates screen as compact, medium, and expanded, and it changes based on that. So for compact screen, we can have, let's say, for example, the bottom bar navigation or a hamburger menu. We can also have the sidebar icons. In the medium screen, we can have the sidebar icons. And in expanded screen, we have sidebar icons with extra text. In the compact screen, we only have the primary body. And in the medium and expanded screen, we have both primary and secondary body. It is easier to implement when you use adaptive scaffold. It provides all this functionality out of the box, which is cool. It has built-in animations, which are also quite nice. But it adds an additional dependency, which you might not want. And you can pretty much implement the same thing using seller route and the techniques we talked about before. When I used it back in the day, around a year ago, it had some performance issues. But at this point, this might be solved. So I don't say it's bad for performance, but I say test it if you need to use it. I think this is actually the content I had. We have plenty of time for Q&A, so if you have any questions, feel free to come. Okay.